Hello everyone, welcome to my new video. So from this lesson onwards, we'll be discussing chapter 6, linear functions. In this specific lesson, I'm going to discuss slope of a line. Have you ever looked at a road going uphill or downhill? In math, we measure the steepness using something called slope. So today we are learning what slope means, how to calculate slope, or how to draw a line segment using slope, how to use a formula to find slope from coordinates. So let's start with the basic formula of slope. Steepness or slope of a line segment is given by slope equal rise over run. What is rise? Rise is a change in the vertical distance. For example, if you're starting something from here and if you're moving up, that is taken as positive. And if you're moving down for measurement, that is negative. And the run is a change in the horizontal distance. So if you're moving right, that is positive, and moving left, negative. So you have to keep this in mind. So this is almost like an XY coordinate. All the measurements above the origin is considered as positive, below the origin negative, and right side the origin positive, left side the origin negative. Okay, let's see how to utilize this concept for measuring the slope. So here you can see a line segment that goes up to the right. This is my initial point. You are not allowed to move diagonally. You can move vertical and horizontal. Only these two movements are permitted. So my vertical movement is positive because it is going up. Again, run, that's also positive because it is going right. But at the same time, you can see, suppose this is my initial point going up positive, but the run is negative because it's going to the left. And look at the third example, a horizontal line. Here, this is my initial point, this is my final point. See, there is no vertical movement upward or downward, which means the rise is 0. But I have a positive run. Or if you're starting from here, you can say you have a negative run. So it doesn't matter because we have the equation slope equal rise over run. So rise is 0. Divided by a positive number or a negative number, doesn't matter, your answer is 0. So slope of a horizontal line is always 0. So look at the first example, finding the slope of a line segment. So here you have 3 different line segments. The first line segment AB. So here you can see the line segment AB alone in this grid, and this is my first point, this is my final point. So I'm going to measure the rise from A. So count how many units are there. 1, 2, 3, 4, 5, 6. So I had to go up 6 units. Since I have moved up, that is positive 6. So rise is positive 6. And from here, 1, 2, 3, 4, 5. I have to move right. So that is run. So run is positive 5. So my slope is slope equal rise over run, and rise is 6, run is 5. So slope equal 6 over 5. Now look at the second segment DC. So you can see DC over here. So starting from here, so going up almost 8 units. So rise is positive 8. Run 1, 2, 3. Run is negative 3. Therefore slope equal positive 8 divided by negative 3. This can also be written as or negative 8 over 3. Both are mathematically correct. And the last segment EF, you can see there is no rise. So rise is 0. Run is 1, 2, 3. You can write either positive 3 or negative 3. So the slope is 0 by 3, that is 0. So we have calculated the slope of three different types of lines over here. Now we are moving on to the next example. Example 2, drawing a line segment given its slope. The question is, draw a line segment with each slope. First question, the slope is 3. See, 3 can be written as not just 3, any whole number can be written as a fraction, and the denominator is 1. And this 3 is the rise and 1 is the run. So what do you have to do? We have the graph here. As the question is not mentioning any specific point, you can choose any point. For example, if I am choosing this point, rise is 3 units and run is 1 unit. So from here, you have to rise 3 units, 1, 2, 3, and run is 1 unit. So this will be my final point. You got 2 points, connect them. So that's your graph. That's it. And our second question, negative 4 over 5. So let's go to the solution. So our slope is negative 4 by 5. See, this can also be written as 4 over negative 5. The textbook has preferred this one, 4 over negative 5. This is the starting point and the rise is 4 units up. 1, 2, 3, 4. Okay. And the run is negative 5, so you have to go left. 1, 2, 3, 4, 5. And we got the destination. Connect them. Connect these 2 points using a straight line, using a ruler, and you can draw the graph. So that is example 2, and I'm moving to example 3. Finding slope using 2 points on a line. This is pretty easy one. Find the slope of this line. And you can see 2 points are labeled. I'm drawing the horizontal and vertical line on the grid like this. And this is my rise. This is my run. Okay, so rise is 1, 2, 3, 4. That is positive 4. And the run is 1, 2, 3, and which is towards left. So that is negative 3. Therefore, slope equal rise over run. That is 4 over negative 3 or negative 4 over 3. And I'm moving to the example number 4, using the formula to find the slope of a line. So this question is something different from the previous 3 examples because here we don't have a graph. Instead, they have given 2 different coordinates. So find the slope of a line that passes through D negative 3, negative 2 and E 10, 5. And after that, we have to check the solution by sketching the line. So what I am going to do, we have 2 coordinates. Let the first coordinate be x1, y1. And the elements of the second coordinate be x2, y2. So what is my x1? Negative 3, y1, negative 2, x2, 10, y2, 5. Here we have a formula to calculate the slope of a line using coordinates. This is the formula. Slope equal y2 minus y1 over x2 minus x1. See, we have all the values to substitute. x1, y1, x2, y2. So you have to substitute the respective values over here. y2, 5. So instead y2, substitute 5. Next is y1. What is y1? y1 is negative 2. See, we already have a negative sign here. You have to use the same negative sign. If your value is negative number, write that negative number inside a bracket. So y1 is negative 2. Again, next is x2. x2 is positive 10. Writing it here. Minus x1. x1 is again negative number. So write that negative number here. Now you have to evaluate this. If you need a calculator for evaluation, that's totally fine. You can use that. So 5 minus minus 2, that is 7. And 10 minus minus 3, that is 13. So the slope of the line is 7/13. So I am plotting the coordinates -3, -2. -3, -2. X value is -3. This is -3. And this is -2. So the point, this is my first coordinate. And the second coordinate is 10, 5. Going to the grid again. X value 10, Y value 5. Okay. So this is my next coordinate. So I have D and E over here. Connect them and you can see the graph goes up to the right like this. Okay. Which means the slope should be positive. So this agree with the positive value of the slope above. So that's all about example 4. Now we can quickly discuss your practice questions. And over here, you can see find the slope of the segment. You have to write the rise value and what is the run here and calculate the slope. And question 3, you have different segments over here. Okay. For example, for AB, write the value of rise. Okay. Rise is 3 and calculate the run and find the slope of the respective segments. And question 4, the slope is given. Okay, so from the slope, write the rise here, run here, and from E move how many units up or down and how many units left or right. Okay, that you have to write it here. Again, label the point E and F and join EF. Same example, I'm not discussing that again. Question number 5. Here you have two coordinates 7 and 11, -1 and -5. Identify the values x1, y1, x2, y2 and substitute the corresponding values over here and you will get that. And here you can see this one coordinate is given, one slope is given. So in this case, what you have to do, first you have to plot this coordinate -2, -1 in your graph. Okay, so -2, -1 should be somewhere here. And after that, the slope is given, which means rise by 5 units, run by 2 units, and connect it. So that's all about this assignment. Give me your feedback on the comment section. And that's everything. Thank you.